Welcome to Rges Algebra 2. This is lesson 27B. We will be, of course, carrying on our instructions at home for as many weeks as we need to. And so I really exhort you to keep on task. We will be having tests, and you'll be picking them up at the class whenever we're getting ready to have one of those, returning them and picking up your graded assignments. So we will continue to have tests and grade them and plug right on through so that you can get full credit for the course, even if for some reason we aren't able to come back. Okay, so this I'd like to encourage you with this scripture. It says, "Be to me a rock of refuge, to which I may continually come." Beautiful verse, beautiful promise. A rock, steady, keeping me steadfast and firm, of refuge, of safety, somebody I can run to when I'm threatened or in need, which of course we always are, actually, and we need to run to the Lord at all times. But the encouragement here, I may continually, this is an invitation, come to me, I may continually come. At all times, he's always available. So I would encourage you in big things and small things, when your heart is unsettled, on behalf of others. There are those around us who, of course, who are worried, and those who are being affected physically, economically. I would ask you to continually come to the Lord on their behalf, as well as your own. So that's a good thing to reflect on today. Now, what we're going to do is we're going to first have a practice quiz on 8.1 through 8.4. So I would exhort you to go ahead and review those sections very quickly, well, as long as it takes, and then come back, take the practice quiz, and I will work it online. So we will not have quizzes graded until we get back into the classroom, but we will have tests on the chapters. Okay, so in lieu of graded quizzes, I will do practice quizzes. I want you to go ahead and work them yourself, and then go ahead and review them and retake them if you miss more than just one or two simple mistakes. Okay, so it's your responsibility to keep up with your learning. Okay, here is your quiz covering 8.1 to 8.4. Again, I will not be taking a grade, but you want to work it as though it were for a grade, preparing you for an upcoming test. I will give the answers and show you how to work them on the next page, but don't so put it on pause and work it out yourself first. I would suggest also that you copy this and put this with the work in your notebook so you have something to refer to. All right. One of the things you must make sure you do is to consider a negative in an exponent different from a negative in a term. Okay, so first you want to just cube everything. Cubing a negative will be negative. The numerator cubed will be 1. The denominator cubed will be 2 times 2 is 4 times 2 is 8. And now this negative in the exponent means flip the numerator and denominator. So it'll still be negative, and now it's negative 8. The next one, you want negative exponents, which means you don't want any positive exponents, okay? I'm sorry, that's a little vague. What we really want is no denominator. I'm sorry, it said negative exponents and no denominator. The no denominator is the priority here. So this is already in the numerator. I'll leave that in the numerator. If you got mistaken by my, I'm sorry if my directions you misunderstood them, but it would be hard to put that. I could not put that, have no denominator. I could have, Okay, so I'm going to divide by this whole phrase, but to divide by it means all of this is in the denominator unless I convert it by taking it to the numerator with a negative exponent, just like that. So that's the answer we're looking for. I apologize if I was vague on that. Okay, positive exponent, next one. So this is the one that has the negative exponent. I want to convert that to a positive by putting it in the denominator. This one, I want no denominator. That's in the denominator, so I need to convert it to a negative. It's to the first power right now, so we'll leave it to the first power. But now it's got to be to the negative first. We want positive fractional exponents, which means I want to remove the radical sign. So I'll be dividing by 3 in the exponent. This will be 3a to the 2/3 rather than 2. Let me just write it this other way here. 2/3. 2/3. There we go. B to the x/3, because it's also under the radical. And c to the minus 1/3. Okay. Just like that. Now I want no denominator. This is in the denominator, so I need to convert it to the numerator by changing the negative exponent to a positive exponent. So this is s to the negative 2 times s to the 7 halves, but I'm not finished yet. I need to add these. You can only add with a common denominator. So now I want to think s to the negative 4 halves, s to the 7 halves. Adding that, I get s to the 3 halves. I identify this as a binomial times a binomial, so I need to FOIL it. In addition, I have the same term, first and second, with only different signs, so my middle terms will drop out. And now I'm going to take the first terms, a to the 1/2 times a to the 1/2. We're adding exponents. Right? And so that would be a to the 1. Okay. Minus, for my last terms, because my middle terms drop out, b to the 1/2 times b to the 1/2. And we're going to add exponents, and that'll be minus b, just like that. If I were to take a to the negative 4 and square it, I'm going to multiply. So this is a to the negative 8th, but it tells me to have a positive exponent, so I need to put it into the denominator. To simplify this one, this is a squared, okay? And so it's going to be in the denominator, so this first term will be x to the 4/6, but I need that simplified, so that'll be x to the 2/3. My next term I want to be positive, so it'll be 3/3, y to the negative 3/3, but I want to make it positive. So first off, I'll simplify it. That means it's y, and then put it in the denominator, just like that. I'm sorry, it's not thirds, it's halves. Sorry about that. So, so we'll put that in the denominator with a positive. I want to factor and have positive exponents, so I'll go ahead and convert this to a positive exponent. This becomes x minus 9 minus, we're going to put that in the denominator, 1 over x squared. And now I'll factor it. This is a difference of squares. This would be 3 squared. This would be 1 over x squared. And so we'll do it positive, and then we'll do the same terms, negative. This is to write in scientific notation. I would put my decimal point right there, only looking at the number part, 8.5. I'm making my scientific notation a larger number, so I'm going to multiply by a positive exponent, and how many places over? It was originally here. I've moved over 3 places. Same way, 0.000039. I only want the number part with the decimal after the first one. I want a smaller number, so it'll be a negative exponent. And I've moved over this way 3, 4, 5 places. For my scientific notation, I'm going in reverse now. I'm going to write these 2 numbers, and I'm going to make it a small number. So I need to move over to the left, my decimal point, to make it a small number, 3 places. The 1 will be the first place, and 2 more zeros. The next one, I'm going to write 675. I need to move to the right to make it a large number, 6 places. This would count for 2 of them, and I need 4 zeros after that. I want to simplify this, and so I will write this in exponential form. This is, if you recall, 2 to the 3rd is 8, so this will be 2 to the 4th power, and it'll be negative 2 to the 4th power. Now, because it's an odd exponent, my answer will be negative. I need to, for every 3, because my index is 3, for every 3 of the base, I will pull it forward outside of the radical sign and then leave under the radical sign whatever's left over. Another way we look at simplifying radicals is we do not want a radical in the denominator. So we need to remove this radical from the denominator. I can look at this as the square root of 3x squared over the square root of 2y. To be able to eliminate this and pull it forward, I need 1 more 2 and 1 more y. So I'd multiply that there, and that way my denominator would be 2y. But I have to, if I multiply it there, I have to multiply it there. And this would be square root of 6x squared y, multiplying that. Now, I could have dealt with this first or second. It doesn't matter, but that's going to come forward because I have 2 of those also. So this will be x, the square root of 6y, all over 2y. Now, 2 things then. 2 more things we're learning about when we're simplifying radicals. So we want no radical in the denominator, and we want to be able to reduce indexes. Now what that means, first off, I'll rewrite that as something to a power. And that would be 5 squared, a to the 4th, b squared. And I'm looking at all my indexes. 2, 4, 2, 6. I can simplify those by dividing everything by 2. And that's what I'll do. So my radical now becomes 3, my 5. Okay. Notice I would not pull it forward because I don't have 6 of them. Okay, I can't pull them forward, but I'm simplifying it. So I'm dividing everything, index and all the exponents. If you have one index or one exponent that can't divide, you can't do this at all. It has to be able to divide into everything. Okay, so this can divide into everything, so we'll have a squared and b. Again, to simplify here, it's got to come out of the radical. We'll write that. I could take this out because I have 4 of them, so let's do both of those. The order doesn't matter so much. I mean, I can have a y out there, and then I'm going to have the 4th root of x. And down here, I'm going to rewrite that as 5 to the 3rd power z to the third power. Now to be able to eliminate this from under the radical, that's also a fourth root, I need 4 of each term. So I've got 3 5s, I need 1 more, so I'm going to multiply by 5, and I need 1 more z. So if I do that down there, I have to also do it up here. So now what do I get? I get y, and now recall, this will have in the denominator, I'll have 4 5s, so I can pull that out from the radical sign. It'll have 4 z's, so I could pull that out. And then in the numerator, I'll just, under the radical, I'll still have 5xz. And then that is more, it's simplified when we don't have a radical in the denominator, even though sometimes it might look like it's not so simplified. Simplifying this next one, I need 6 to pull it forward. This is the only one that qualifies, so I'll pull 6 of them out, and that will leave me with a to the 4th, b squared, x to the 4th, y to the squared. And notice all my indexes can divide by 2. 3a squared bx squared y. And so that's my simplification there. And finally, the last one. In a right triangle, I'm going to use c equals the square root of a squared plus b squared. Make sure you have the Pythagorean theorem memorized there. And we're going to plug in. C equals 3 squared is 9, plus 6 squared is 36. C equals the square root of 36 plus 9 is 45. Now, what is 45? We want to simplify this. 45 is 9 times 5, or 3 squared times 5. And so this can come forward because I have 2 of them. So this is 3 times the square root of 5. All right, that's your quiz. Now, if you have any misconceptions and misunderstanding, and let's say you review it then again, you saw what you did wrong and you understand it when I've gone over it, that's fine. Then just practice it. If you still don't understand it, you need to text me. Recall that whenever, because we're working from home here, you want to text 505 301 1357 and questions. Identify who you are, identify the class you're in, and say it's practice quiz 20, I don't understand number 17 or whatever. Okay? And I'll address it on the next test, or the next tape, I'm sorry. All right, now let's go on to something else. Now we are showing you the answers to 8.5, 1 through 25 all, and I'm going to review a few ideas for you. First off, the first one here, my problem was the square root of 3 and the 4th root of 2. So I need to convert them both to the same. So I'm going to convert this to a 4th root. Okay. And so I need to raise, since it's a square now, I need to raise this to the squared, to the 2nd power. Okay. And that's how we get that answer. So the next one, the one was to the 3rd power, one was to the squared power, so I need to convert them both to the 6th power. Okay, let me show you that one. So this is the problem, the original problem. If they're both going to be to the 6th power, sorry about that, I need to multiply this by 2, so I'm going to raise this to the 2nd power, which will give me 4. I'm going to multiply this by 3, so I'm going to have to raise this to the 3rd power, and that's 125. Okay, so I'm going to come down now until I see another one that might be puzzling. Number 4, might surprise you a little. My original was the cubed root of 5 and the cubed root. Whoops, I'm sorry, let me write the original problem. At first blush, you might assume that both of these are going to be converted to the 6th power, but notice that this is 6 and this is 2 squared, so I would actually reduce this one by dividing both by 2, and I would get 2 divided by that for the second term, okay? So I think the rest of them on this page are pretty much of the same ilk, but go ahead and text me if you can't figure out any, and now let me on the next page go ahead and continue to give answers from 12 on. Okay, so this is the rest of these problems. I'm going to let you, since you've got the answers, and a lot of them, I said skip these. These two are similar to it. You just need to, in order to compare them, you need to have them in the same, with the same index. Okay, and so go ahead and look at those. Skip these. They're similar, just more complicated. The 2 word problems are done here for you. And again, feel free to text me with any that are confusing. Now, I'm going to have to do a part 2 in order to explain the new concept of 8.6.